The neural mechanisms of depression. The part that does not look physical but is. Depression is often described in emotional terms: low mood, lack of motivation, feeling disconnected. But those experiences don't just appear on their own. They come from changes in how the brain is functioning. That's the part that feels less obvious. It doesn't look physical, but it is. Why it is not just one area of the brain. It's more complex than that. It involves networks. The prefrontal cortex, the amygdala, the hippocampus. These areas are connected. Their interaction affects mood, memory, and emotional regulation. If multiple systems are involved, how do small changes create such noticeable effects? The role of neurotransmitters. Neurotransmitters like serotonin, dopamine, and norepinephrine are often mentioned. They help regulate mood, motivation, and attention. When their balance is disrupted, communication between neurons changes. But it's not as simple as low serotonin equals depression. The system is more dynamic than that. Step 1. Changes in neural communication. Neurons communicate through synapses, using neurotransmitters to send signals. In depression, this communication can become less efficient in certain pathways. Signals related to motivation or reward may be weaker. That change affects how experiences are processed. Step 2. Altered activity in brain networks. Different brain regions show changes in activity. The amygdala, which processes emotional responses, may become more reactive. The prefrontal cortex, which helps regulate those responses, may become less active. This imbalance can make negative emotions feel stronger and harder to control. Step 3. Changes in the hippocampus. The hippocampus, involved in memory and learning, can also be affected. Chronic stress is often linked to depression. It can influence its structure and function. This may affect how memories are formed and recalled, especially negative experiences. Step 4. The role of stress hormones. Stress hormones like cortisol play a role in this process. When stress is prolonged, cortisol levels remain elevated. This can affect neural function and contribute to changes in brain structure. It's not just a short-term response. It becomes part of a longer pattern. A pattern that feels familiar. I've noticed how mental states can shift even without a clear external reason. You feel less motivated, less engaged, even when nothing specific has changed. That feeling can seem purely emotional, but it reflects underlying changes in how the brain is processing information. Why it is not the same for everyone. Depression does not look the same for everyone because the underlying changes can vary. Different pathways, different responses to stress, different patterns of neural activity. That variability makes it harder to define as a single condition what this means for treatment. Understanding the neural mechanisms helps explain why treatments vary. Medications may target neurotransmitters. Therapy may help reshape thought patterns and neural activity. Lifestyle changes can influence stress and brain function. Each approach affects the system in a different way. The part you don't notice at first. One thing that stands out is how gradual these changes can be. It's not always a sudden shift. It can build over time, which makes it harder to recognize early. You adjust to how you feel, and it becomes your baseline without you realizing it. Final thoughts. Depression is not just an emotional experience. It is a result of changes in how the brain communicates, regulates, and responds. Multiple systems are involved, and their interaction shapes how it feels. And once you start thinking about it in that way, it becomes easier to understand why it is complex and why it takes different approaches to address it. Thanks for watching.